Okay, so sorry I'm not there again, guys. But I don't want to postpone starting chapter 5 any longer, so we're starting chapter 5 today. Hopefully everybody is watching this video. If you have any friends or anybody at your group who's not watching the video, please tell them that this lesson is important. I'm going to apologize in advance because I'm going to yawn like crazy. But make sure everybody is watching it just because everybody needs to know what to do and how to do it, okay? So here we just do a little quick review of slope-intercept form. It is called this because it gives us the slope and the y-intercept, okay? Now, we normally call the slope, we started off calling it the growth, which is fine, but I do want you guys to call it slope. And then we want to remember that m, which is slope, is rise over run. So we can make little slope triangles if we were to have a graph like this. Let's see here. Let's say this is our graph. And this is our line on the graph, right? The slope, if you found two lattice points, you can draw a slope triangle, like so. So this would be your rise, and this would be your run. And then you would write it in fraction form and simplify if you can to get the slope, okay? And then your y-intercept, which you guys have also called the starting point, it is always when x equals 0. So it's on the y-axis here. So that's the y-axis, this is the x-axis. At x equals 0, we're going to be right along the y-axis here. So for this line, this green dot here, that is our y-intercept. That is where our line crosses the y-axis, okay? So the y-intercept would always be written as a point 0, comma, big yawn, 0, comma, b. So whatever this number is, that's what your y-intercept would be, okay? All right, so we're going to practice a new skill. We've been working a lot on solving equations, and that's why I reviewed it with you last week, and I've assigned Khan Academy assignments on it. So solving equations is super important, not just with trying to solve for a variable, but also using it for a situation like this problem. So it says here we have a lot of experience working with equations that compare two quantities. For example, while working with the height of a tree, you found the relationship y equals 4x plus 5. That is talking about John's giant redwood tree that we did last semester. It was one of our lessons, I believe in chapter 4, it's either 3 or 4. But we did talk about John's giant redwood, and we wrote an equation that represented the growth of John's tree. This equation compared x, which was the number of years after the tree was planted, to y, which was the tree's height in feet. So we want to use this equation, y equals 4x plus 5, to answer the questions below. Now, y equals 4x plus 5. The 4 is in the place where m is in y equals mx plus b up here. That is your growth or your slope, right? So that's telling me that this tree grows 4 feet per year. And the reason why it's the per year part is because that's 4 times x, and x is the number of years after it was planted. So x represents years, right? So we grow 4 feet every year. So that's why we have to multiply 4 by the number of years it's been growing. Now, in addition to that, the tree was already 5 feet tall when John had planted it. So that was our starting height of the tree. So make sure to take a moment to pause and understand that concept, and think about why this equation is written in such a way where y, which is the height, equals 4 times the number of years since it was planted, plus 5, which 5 was the starting height. That's how tall it was whenever John planted the tree, and then it continued to grow 4 feet per year. Okay? All right, so in that equation there, y equals 4x plus 5. It was super quick for me to determine, okay, 4 is the growth and 5 is the y-intercept, or the starting point, right? So you can find the growth rate and starting value for y equals 4x plus 5 quickly because the equation was already in y equals mx plus b form. But what if the equation is in a different form? We're going to explore this situation below. Sorry, I keep hitting my glass of water. So the line negative 6x plus 2y equals 10 is written in standard form. How can we rewrite it to look like the slope-intercept form above? Explain your steps to the side and show your work. Okay, so we need this to become y equals mx plus b in this format, right? So this basically is telling us to isolate the y. All right. So we are going to do steps. So my first step would be, of course, I'm going to draw a line down the equal sign real quick. And then I notice that the y is on the left side of that line. So I'm going to move everything else to the right side. So my first thing is to move this 6x over. Now I cannot combine 10 and 6x because the 10 does not have an x. So my first step is move 6x to other side. And I added it because it was a negative. So I did the opposite to zero it out here. And now I'm left with 2y equals 6x plus 10. And I just wrote the 6x in front of the 10 just because that is getting closer to my y equals mx plus b format. Let's assume that you did not think of that and you just wrote it like this. We'll still get the same answer. Okay? So now I see that the y is being multiplied by 2 right here. This is 2 times y. So I need to divide both sides by 2 to get the y by itself. Divide both sides by 2. And that will undo the multiplication there. Now these here, it would be all over 2. And what happens there is you can simplify it by dividing each of those terms by 2. So this on the left would just become 1y. 2 divided by 2 is y. This one we could rewrite it if you'd like. It's really 10 over 2 plus 6x over 2. And I could have written it like that right away. But I just want to show you guys that dividing the whole side by 2 is the same as, since these were being added, you can split them up. Because that's like they have a common denominator. So if I had like 10 over 2 plus 6x over 2, I could rewrite that like this because they have a common denominator. Just like if I had like 3/7 plus 1/7, they have a common denominator, so I can rewrite that fraction like this, which would give me 4/7. So that's important to recognize how you can switch between these two because of a common denominator. Okay. If you're not, well, let's see here. I mean, I guess if you're hearing me, so make sure you're listening. Wow, my handwriting's horrible. You're listening to this video. Because I've seen so many students not listening to the videos, and I'm like, what's the point? You're just copying it down and your brain's not learning, you know? So make sure you're listening. Okay. So then this would simplify to y equals 10 divided by 2 is 5. 6x over 2 is 3x. Now if you wanted to rewrite this into y equals mx plus b form, you just have to switch the position of where 5 and 3x's. So this is the same as 3x plus 5. So now you can quickly see that 3 is the slope and 5 is your y-intercept. So you could say, so 3 is the slope, 5 is the y-intercept. And now that is easier for you to graph it as well. You would be able to plot the y-intercept and then use your slope of 3 to find more points along the line. Now remember, you could always rewrite this as rise over run as 3 over 1, right? Or even 6 over 2 or 12 over 4 or anything that you would divide to equal 3, you could write that as the rise over run. which actually, like right here, that would work. But to simplify it, it's 3. Okay? So that's what you guys are going to practice on this page here. All right? So I will do a few of them. I have not decided if I'll do all of them yet, but I will do a few. Okay, at least. All right, so this one here, of course, draw your lines. Draw all of them if you want. Make sure you don't write too big because there's several problems on this page. Okay, so again, it's isolating the y. So first you want to make sure, you want to find where the y is, right? So I'm going to first identify the y, and it's right here. This one's nice. It doesn't have a number attached to it like this one did up here, right? My y up here had the 2 attached to it. So this one won't have as many steps. It's a lot simpler. So try to solve it first. How could you get the y by itself? What you guys will have to do is just one step really is subtract 2x from both sides. So minus 2x, okay? And this would zero it out, and I subtracted it because it was a positive up there. So now I'm just left with y here. 3x minus 2x is 1x, or just x. And then I still have that minus 7. And that is in my y equals mx plus b form. Perfect. So now you have to identify your growth, or the slope, m. And here, that's really just a 1, right? It's 1x. So my growth is 1, and this is slope. I wish I would have changed that before I did this. All these, I would like them to say slope. That was my bad. Slope. Okay. And then our y-intercept there, the b is -7. So that means that my line would cross the y-axis at -7, and it would have a growth of 1. So if I wanted to sketch that type of graph, you could do it pretty quickly. This is not perfect by any means. But 1, 2, 3, 4, 5, 6, 7. So let's say that's at -7. And having it be a growth of 1 just means it'll go up 1 over 1 every single time. So it's going to look something like that. It would cross right here at 7 because it's going to go up 1 over 1 every single time. So yeah, so that's how it would look. And if you were to type this in, y equals 1x minus 7, type in Desmos graphing and see how the line looks. And this is for those who probably aren't listening still. The line looks. I hope they're listening. All right. So I want you guys to do that is as you guys are getting these linear equations, this is what we call a linear equation, see what the line looks like in Desmos graphing to kind of get more used to what a line looks like from its equation. All right. So again here, first of all, you want to identify the y, and I see the y is right here. So it's on the left-hand side, so I want to move everything else over to the right. And it looks like I'll have more than just one step, like the first one. So what you want to do here is move, I would subtract x from both sides. So I'm just going to write subtract x minus x. And then here I'm going to subtract it from the other like term with the x there. So I'm left with 2y equals 3x minus x is 2x. And then I bring down that plus 4. Okay. And then now my next step is to divide everything by 2. I have to undo that multiplication here of 2y, 2 times y, divide everything by 2. Okay. So we're left with y equals 2 divided by 2 is 1, so it's just 1x. 4 divided by 2 is 2, so it'll be positive 2. And there we are. That is in y equals mx plus b form. So our slope here, what is our m, the number attached to x? It's going to be 1. And b, y-intercept, will be 2. Positive 2, positive 1. So if you wanted to see a sketch of this one, so it's going to cross at positive 2 here. And again, your slope is just 1, so that means it's going to be going up 1 over 1 every single time. So it's like a perfect diagonal line if you wanted to think of it that way. So this here would cross at negative 2. We'll keep going on forever. Okay. Again, type that into Desmos to see what it looks like. Okay, Desmos graphing is an awesome tool for you guys to learn what a line looks like on a graph. All right, so here I see, there's y's in 2 spots here. I need to get those combined right away. Like, that's your first thing. So I noticed that if I were to subtract the 2y, then I would end up with just 1y on the left there. So I'm going to go ahead and subtract 2y. And always assume these are from both sides, okay? So minus 2y. And I subtracted because it was a positive 2y, so that zeroes it out. On the left here, I'm left with just 1y. Then this plus 2 equals negative 5x, because I zeroed out the 2y's. Okay? So I'm getting closer, right? The y is almost all the way by itself. I ended up with 1y, so it's really pretty. So now I'm going to go ahead and subtract 2. And this is why it's super important. Like, sometimes I see you guys not write the variables or write a variable that you're not actually subtracting or dividing. So make sure that you are writing down exactly what you're doing. So like here I'm subtracting 2 here, subtracting 2. Now I cannot combine these two. They're not like terms. So I'm just going to write them side by side. So on this side I'm left with a y, and then that is a negative 5x, and that was minus 2. So that there is in mx plus b form. So this tells me that my slope is negative 5, and my y-intercept is negative 2. 2, negative 5. Now this one's going to be a super steep negative looking thing here. So it's going to cross, actually I should draw that a little bit different. So 1, 2, 3, 4. Oh, it crosses at negative 2, my bad. So my y-intercept is going to be right here at negative 2, and then my slope, I'm going to be going down 5, so 1, 2, 3, 4, 5, and then over 1. So it's going to be a super steep line, something like this. So again, plot it in Desmos. Plot in Desmos for those people who aren't listening to my video. All right. Okay, so this one I see some parentheses. I'm going to move this out of my way. So the first thing we have to do there is distribute to simplify that. We cannot do anything right now. Well, actually, technically in this one, you could divide everything by 2 because these are even numbers over there. So that is one way to do it. And then that would cancel out this, leave us with y minus 3 equals x minus 3. But let's assume that you guys didn't realize that. I think a lot of you would have distributed, and that's totally fine. So I'm going to put here, distribute the y, or the 2, sorry. Distribute the 2 to the y in the negative 3. So 2 times y is 2y. 2 times negative 3 is negative 6. Okay. So now our next step is we notice that the y is on the left-hand side, so we want to just leave it there. Let's add this 6. So add 6 to both sides. So here we have plus 6, and I did that here to zero out, and this just happens to zero out as well. So I canceled out my 6's, which is totally fine. So we're left with 2y equals 2x, okay? So now we're almost there with getting the y by itself, but this division of 2 there, or I'm sorry, this multiplication of 2 needs to be divided by 2 to cancel it out. Then I also end up canceling out that 2. So I'm left with 1y equals 1x. And that is in y equals mx plus b form. So this is the same as y equals 1x plus 0, right? You would simplify that to be y equals x. So that means that my growth is just 1, right? The number in front of x here is just 1x. And my y-intercept is just 0. Okay? And I got that because this is equivalent to the statement that we got, the equation we got. Whoops, I forgot to write down my step here, divide by 2. So what this line would look like, whoops, sorry, I didn't mean to do that. What this line would look like is pretty perfect. Y equals x means it crosses at 0, 0, and it goes up 1 over 1 every single time. So its line is going to look just like this. And if it was negative, y equals negative x, it would look like that. It would go perfectly diagonal downward. So that is what the line y equals x looks like. Yeah. And no, I did not say for you guys to sketch these, but it's really, really good for you guys to start to sketch and recognize what the lines look like. All right, 2 more left. Looks like I'm doing all of them. Okay. So here I want you to pause and just think, okay, what do I have to do first? I would take care of the multiplication, right? So this negative 3, we want to distribute that. And it is the whole negative 3, right? Not just 3. There's a negative there. So your first step is to distribute negative 3. Some of you might have subtracted the 5, right? That would be fine as long as you only subtracted it from this 2. But I always tend to distribute first. So here we have 5, and then negative 3 times x is negative 3x, and negative 3 times 1 is negative 3. And then looking here, I don't see anything I can combine on the right side, but on the left side, I can combine 5 minus 3. And I'm talking about that 3 there, not the one with the x. Okay? So 5 minus 3 is 2. And then I still have that minus 3x here. Equals 2y minus 3x plus 2. This one's going to be a tricky one. Alright, so I'm just going to start moving things around. I noticed that the y is on the right-hand side, so I'm just going to leave it on the right. So I'm going to move everything else away from the right. So here, first of all, I see that 2, so I'm going to write subtract 2. So right here, minus 2, minus 2. And those all end up canceling out. And that's okay, right? That just means it's 0. So now I'm left with negative 3x equals 2y minus 3x. And some of you might already see what's about to happen here. So now I need to get this negative 3x away from my y. So to undo the negative 3x, I need to add 3x to both sides. That would 0 out, and this happens to 0 out as well. Now that's not the end of it. You need to write 0 equals 2y. That is so, so, so important. I'm going to write over here because I'm out of room. So 0 equals 2y, and we still need to solve for y. Okay, still need to do it. So our next step is to divide by 2. So if you divide both sides by 2, 0 divided by 2 is just 0. And this is your equation. It has a growth or a slope of 0. So that means it'll be a flat line like that. And the y-intercept is 0. So what this graph would look like, if you guys were to graph it, you would get a line. But the line is going to be right along your x-axis. Y equals 0 is the x-axis. Right? It has a slope of 0, so it's going to go left to right. It's not slanted at all. If it was up and down, this is an undefined slope. It would have too many outputs for one input. But this line here that I drew in pink, that is a line. That is the x-axis. It is y equals 0. All right. Okay, so now this one here, same idea. First we want to distribute. There's two things we can distribute here. I'm going to write them off to the side here. So first distribute negative and that 2. Oh, I guess I should write here. 2. All right, so this negative here can be distributed, and this 2 here can be distributed. So over here, I'm still left with x, and then negative times y is negative y, negative times positive 2 is negative 2, 2 times 2x is 4x, 2 times 1 is 2. Okay. Now I'm going to identify where the y is, and it's right here, and it is a negative y, so I'll have to deal with that negative later. So now my second step, I want to move this x out of the way. So subtract x. So right here, this x, I want to move that x away. So I have to subtract it from both sides because it is a positive over here. So then that leaves me with negative y minus 2. 4x minus x is 3x. Bring down this 2. And make sure that you're pausing. I'm moving pretty fast, so if you need more time, just pause the video. That's what's nice, is you can shut me up by just hitting pause. Okay, so now the next step is I still need to get the y more isolated, and that 2 is in the way. So to undo subtraction, whoops, I didn't mean to do that, 2. So to undo subtraction, I need to add. So I need to add 2 to both sides. And that's this 2 here. I'm adding it to this 2 over here because that 2 does not have an x either. So I can combine them. So here I'm just left with negative y equals 3x. Just bring that down. 2 plus 2 is 4. Alright. These are the times where like I start to see a lot of random mistakes. Like I'll see somebody put 1, like they assume they were dividing. If it was a different number, they might have like accidentally multiplied. So just make sure that you're very clearly showing what you're doing here, like I do on my steps, okay? Organization matters. All right, so here I have a negative y. There's multiple things you can do here. You can either divide everything by a negative 1, or you can multiply everything by negative 1. That would change that y to a positive 1y. So either way, you can do it. The most common way I see students gravitate towards is just divide by negative 1. Because a negative divided by a negative would make a positive, and this will still keep it as positive 1y. So dividing by negative 1, this becomes a positive y. 3x divided by negative 1 will be negative 3x. 4 divided by negative 1 is negative 4. And now we are in y equals mx plus b form. And that gives me my slope. Slope is negative 3. My y-intercept is negative 4. And make sure that if you guys have been wanting to like do any color coding or anything, this is a great page to study. And you will have some Khan Academies on this. And there's colored pencils and whatnot over underneath the TV in the classroom if you need them. Just make sure you put them back. All right. Email me if you have any questions or need any help. And I hope to see you guys soon. Have a good one.